So far that the ions that we have come across are monoatomic ions. Monoatomic ions, if you remember, are the ions that are made from one atom only. Example, say example Na plus. This is a cation which is created from one atom of sodium, or oxygen 2 minus, again made from one atom of oxygen, or barium uh, cation made from one atom of barium, so on and so forth. These are monoatomic ions because you need only one atom to make each of these ions, whether they are cations or anions. Polyatomic ions, on the other hand, are ions that are made from a combination of several atoms, more than one atom, such that that entire piece works as one unit, sharing that overall charge. The overall charge for that ion is distributed for that entire piece. There are quite a few examples of polyatomic ions. Your book has a table um, that of some common polyatomic ions that you will need to memorize. You will need to know these polyatomic ions. In other words, basically, when we talk about nitrate, that which is an example of a polyatomic ions, you will need to know that this is an ion that is made up of one nitrogen and three oxygens, such a way that the overall charge is, is -1. Similarly, if we talk about hydroxide, it's a different polyatomic ion made up of one hydrogen and one oxygen, such that that entire piece, that entire unit, shares a single negative charge again. So please, for now, refer to that table and go ahead and write out these the formula and the charges of these ions. So sulfate is SO4, charge of 2 minus. Ammonium is NH4, charge of +1. Phosphite is PO3, charge of 3 minus. Perchlorate is ClO4, charge of -1. So please memorize these the table of polyatomic ions that is in your book, all of them, so that we can then get to use them. Now, when we write chemical formulas of ionic compounds that have polyatomic ions, the process is exactly what we used in the previous session. That doesn't change. The cation comes before the anion in the chemical formula as before. The goal when you're writing the chemical formula of the formula unit, the goal is once again to combine cation and anion in a ratio such that the overall charge is 0. So those steps still remain the same. So for example, if you were to ask to write the chemical formula of an ionic compound when beryllium combines with nitrite, it's exactly the same process, which is figure out the ions first. Beryllium is, let's solve the first one. Beryllium is a metal in group 2A. So if beryllium is a metal in group 2A, this will donate 2 electrons from its valence shell to make an ion beryllium 2 plus. Nitrite, since it's a polyatomic ion and you need to memorize these, there is no hint. You cannot figure out any of the polyatomic ions just from the periodic table. This is something you do have to memorize. So nitrite, we know, is NO2, charge of the unit is -1. So now if you're going to combine these two ions together in a ratio such that the overall charge is 0, that ratio would have to be Be, cation first, NO2, and then we need 2 NO2s. So the best way to show that is to use parentheses for this unit and then another 2 outside of that parentheses. When you write this chemical formula, it is telling the reader that the formula unit has one beryllium ion with a charge of 2 plus and two nitrite ions together. That's what the chemical formula is telling us. Okay, using this as a hint, please go ahead and complete this list of chemical formulas. You may want to pause the recording while you work on this. If you are done, you probably got these answers. Once again, please remember that the cation goes first in the chemical formula and followed by the anion. And then the other goal when you're writing the chemical formula is that the subscripts give us the lowest whole number ratio. Of cation to anion. Okay, so now that we know how to write the chemical formulas of ionic compounds by working out the charges on ions or by remembering the polyatomic ions, let's just very quickly talk about how do we identify an ionic compound. An ionic compound by definition is a compound that is made up of a cation and an anion. And that is what is very important for you to remember. So ionic compounds, whenever you are looking at one, you should be able to identify a cation. And this I cannot emphasize enough. So please pay very close attention. If you can identify a cation in the chemical formula, there will be an anion. But if there is no cation, there cannot be an anion. And I'll give you a few examples to explain what I mean. But this is something very important for you to understand. Now, non-metallic atoms will always make anions if they are combining with metallic atoms to make cations. Metallic, so you do have to keep that in mind. Now, to determine if there is a compound is ionic or not, look for a cation, because as I said, if there is a cation, there will be an anion. But if there isn't a cation, there cannot be an anion. Cations are easily figured out because cations will either be a metal atom or a polyatomic cation. And for now, the only polyatomic cation that you will come across for now would be ammonium. Ammonium, if you remember, is the polyatomic ion made of 1 nitrogen and 4 hydrogen atoms with an overall charge of +1. So with this idea, if I asked you, is this an ionic compound or not? Yes, this is an ionic compound. Okay, how about, is that ionic compound? Now, please be very careful. As I said before, look for a cation first. Is there a cation here? In other words, is there a metal here? No, there is no metal. Is there ammonium in this compound? No, there is no ammonium. Therefore, there is no cation. If there is no cation, can there be an anion? No, there cannot be an anion. So this compound is not an ionic compound, even though it seems like they have the same anion. So you either have both ions or you have neither ions. Please keep that in mind. So look, using the same idea, is this an ionic compound? Yes, it is, because here is a cation because it's a metal. It's coming from a metal, and therefore this would be the anion, which of course you might recognize as the hydroxide ion. So yes, this is an ionic compound. Good. Okay. How about this one? Is this an ionic compound? Yes, this is an ionic compound too because there's no cation from a metal here. There is no metal in this compound. But what you do have is a polyatomic cation ammonium. So please look out for the ammonium. It will trick you if you're not paying attention. And of course, then the rest of the unit is the anion, which once again is the hydroxide in this case. So the compound overall is an ionic compound. But what about, is this an ionic compound? So is there a cation? I mean, it seems to have that again, which in the previous two examples was an anion, but is it an anion in this compound? So let's analyze. Look for a cation first. Is there a metallic element in there? No, there isn't. Is there ammonium in there? NH4? No, there isn't. So if that's the case, then this is not a cation. And if this is not a cation, then that cannot be an anion. And if that's not an anion, this compound is not an ionic compound. So once again, please look for a cation first, because if you can find a cation, there will be an anion. But if there is no cation, there cannot be an anion.